Hi everyone, we're going to get started in just a moment.
The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, we're going to get started in just a moment. Okay, hi everyone, this is Steve Hess. Welcome to the 16th webinar in a series. I am the Director of User Experience at OpenBOM, and I'd like to welcome you all to the first broadcast of the year. I'm wondering if anyone can maybe raise a hand if you can hear me, or maybe post a message in the chat or something. I think the audio is working properly, but would love a confirmation if anybody can just post a message. Great. Okay. Okay. I see some new names have joined, as well as some familiar names. So Happy New Year, everybody. Let's go ahead and get started. Today's topic is purchased assemblies and bill of material techniques and BOM techniques for using purchased assemblies. We're going to dive into what those are and everything else in just a moment. Okay, as we start off each webinar with a quick set of the rules, this is a 20-minute or less discussion about purchased assemblies and what they are and how we manage them in bills of material. So this is a live demo here, and there'll be time for questions at the end, and I make every effort to make this a marketing-free event. Okay, and let's just start off with some definitions as well. I will be sharing this. We'll be sharing this video as well as this slide deck out, so you can dive into this in more detail. No materials, catalog, part number. These are things that we've been covering in all of our webinars up to date. And in this context, an assembly refers to a collection of parts or other subassemblies generally created in CAD. And I say that very generally. It certainly is not the case. So many of these principles certainly apply to, just keyed in, keystroked bills of material. And a purchase assembly, in the context of this discussion, is going to be an assembly which we buy, which comes assembled. So these are things like pumps and bearings and circuit boards and other things that we don't typically design, that we don't typically manufacture ourselves. We may design them. As a matter of fact, we may have all of those components even rendered in our assembly, but in the end, we want to buy it. So we're going to dive into a few more reasons around why we might want to do that, and what are the cases when we would build versus buy assembly. So we're going to cover two items here in today's webinar. Actually, we're going to cover one, because as this thing started to grow a little bit, I quickly found that I just couldn't compress both these topics into a single webinar in any meaningful way. So we're going to talk about today managing purchased assemblies which are authored in CAD. We're going to use going to bring a CAD demo. We're going to build a bill of material. We're going to cycle back through a couple of times to kind of see what the impact is of changing the behavior in CAD and how it reflects on our bill of material. So I would like to invite everyone to go ahead and post any questions as we go along. I'll try to keep an eye on the questions area. There'll also be time for questions at the end. And thanks for confirming that you can hear me. That's great news. Okay. So what are some examples of purchased assemblies? We just listed a few of them. Here are a few more. It might be sheet metal, could be a water wheel, could be a caster wheel. If we had more time, I could tell you the stories of how many caster wheels we must have modeled in one of my jobs as a mechanical engineer. It was frightening how many people just modeled their own caster wheel yet again, rather than buying using a purchased assembly caster wheel and a standard part number. So in my company, we must have had 15 or 20 different models as well as part numbers of essentially the same caster wheel. Several things happen when we do that. When we ignore the purchased assembly workflow, what happened in my own company was we would take a new part number for yet another caster wheel, another 4-inch caster wheel. I'd put it into my assembly. I don't get the benefit of any reuse in my modeling because we remodeled this thing. It shows up as a new item in my BOM. It's got a new part number. And the worst case of all, it gets down to my purchasing department. And in my colleague's assembly, he's buying, 12 caster wheels. And, in my assembly, I'm buying 8. They're exactly the same part. We've got different part numbers, and we don't get the 20-piece price. We get the 8 and 12-piece prices. So it's important to think about, especially up front in your design, where can I optimize, where can I get some value for my company, especially on those things that maybe have high quantities and have high discounts for those quantities, screws and tape and other things. It's really important that we think of that as a single assembly within my company. We use it in CAD. We make sure that it's reused in our bills of material. And ultimately, when it comes down to the end of, and my supply person is buying it, they're buying a single part number to fit all uses, and not something else. So same thing applies to circuit boards, although it's a slightly different workflow. In some cases, the engineers will design and build their own circuit boards, in which case it does appear as an indented item in a bill of material, and all the individual pieces are listed, and we go off and have that circuit board purpose built. But if I'm using an Arduino or some other controller or something in my design, very important that we image that in our design so that we have the right spaces and setbacks and all of the other things. Maybe we're doing heat modeling, but yet we have a single part number for that. Bearings, pumps, and everything else, all the same stories. And we're going to go through a use case of a bearing here in just a moment. Yeah. So let's ask ourselves, what are some of the reasons that we might need or want to use a purchased assembly, and when can those occur? I've sort of listed them in order of, in my experience, what I found them to be important. And as an engineer, most important thing to me is, gee, I really want to have all the parts for this pump or electric motor, modeled in my CAD model, so that I can assign materials and I can get weights and do stress calculations and heat, other things like that. So if I'm in a case where I'm in a highly engineered environment, really important to have the actual components modeled, even if they're enclosed in something that we're eventually going to buy. Another use case which I really like and have found to be quite useful is the case where I'm building a sprinkler controller, and it has a housing, and for the first 10 units of the prototypes, we're going to build that housing in-house. A guy on my brake's going to sit down, he's going to bend that thing up. After serial number 11 and forward, I'm going to start buying this from my sheet metal vendor. So a couple of reasons for that. Perhaps during those first 10 units, I was negotiating with my sheet metal guy on price and delivery once our design was finalized. It could just be that we're sort of optimizing our designs, reaching some maturity, and we're going into high volume manufacturing, and we want to optimize that, get a better price. So the case is the first 10 serial numbers, I need all those bits and pieces in my bill of material. The guy in the shop floor has to put it together. Serial number 11 and beyond, that's going to come in as a single line item. How do we deal with that condition? And then another one that I like, comes to maybe you're pulling in some catalog parts from Grainger or Cadena's or some other places, Bimba cylinders. You got a manufacturing partner who designs and builds this piece for you, and you just want to represent it. You want to render it properly in your CAD system. Maybe you create marketing materials or other high quality images. You just want the thing to look right. So I'm gonna put that Bimba cylinder or that controller in my CAD system, make a really nice glossy marketing picture of it, yet I still don't want to deal with all the bits and pieces inside. I'm sure there's some others. I'd love to hear from you on what they might be. Okay, so let's take that use case that we just mentioned there. This just kind of rolls a couple of those use cases together, but I'd like to go through one in particular, and this is the bearing use case. Classic engineering problem issue. I pull a bearing from Grainger or some other provider. Maybe it comes in as a group of SAT files, or perhaps it comes in as SolidWorks files or IGES files or something, and it has all the parts in it. So as an engineer, I drag that into my CAD model, and I end up with the situation that we see here on the left. I've got a bearing that I'm going to be buying from my bearing vendor, but yet I have all of this other sub-level components, races, and there's going to be 24 of these rollers and other things that I'm just not interested. Super important that they're modeled accurately in my CAD model. Here I've got a Formula One braking system that sits out on each wheel. Critical that dimensionally and everything else that they're accurate, but I certainly don't want these things showing up in my in my bill of material. I don't want my purchasing people thinking that they've got to go out and buy bearing inner ring number 2. So how do we deal with that case? And again, in this webinar, we're gonna take sort of a CAD centered approach. So let's take a look at that. If we went ahead and ran a bill of material for that design, this is what we would get. We would get a part number, and in this case, I'm using some words for part numbers to kind of help us through the webinar. But typically, this would be a number, and I'm getting these this is line 3. I'm getting 3.1, 3.4, and on with all the other little bits and pieces. I don't want that. I just want this thing to show up as a bearing. I realize it's an assembly. It's going to be a type purchase assembly, but I don't want these indented levels. So I'm gonna kind of return back to my CAD system now, and we're going to dive down into this particular bearing. Open it in my CAD system. Each CAD system. I'm going to try to do this sort of representatively, because each CAD system sort of has a different way of achieving the same goal. And so I want you to think about, kind of at a higher level what the process is here, and then we can deal with the details of each CAD system if you need help on that. So we're going to go into this particular bearing, maybe visit its configuration or someplace where my CAD system keeps track of, how this bearing file is represented. And I'm going to say to my CAD system, hey, look, everything, all the child components of this bearing are going to be hidden. Okay, that's pretty simple. So we hide those, and we save our file, or we do whatever the next step is. And then we see when we go ahead and run the BOM again, we are going to have a single line item, still an assembly, but I'm not going to have any indented levels underneath that. That's exactly what I want. Still have all the information mastered in CAD. Just when I get to what we call the buy level, I'm only buying that one assembly. So that solves, and that use case there solves a number of those stories that we talked about there in the beginning. So let's take a little deeper dive into, and with a live demo. And again, I'm trying to time box this around 20 minutes. So we've got about 5 minutes left. Let's take a deeper dive into a live demo, do a few things, and then I'll take some questions. I'll take some questions from you as well. So one moment. I'm going to use SolidWorks in this case, and OpenBOM. SolidWorks has a nice OpenBOM integration, and so it'll meet our needs for the purposes of the demo. The other CAD systems with respect to OpenBOM also have similar integration. So here's our design in SolidWorks, and you can see here I've got these bearings. I've also got a clutch pack here that just has a bunch of clutch disc plates in it and some other things. Yeah. So I finished modeling this, and I say, hey, let's build a bill of material. So I'm just doing this. This is right out of the get-go. I've just modeled these parts. I'm throwing together a bill of material. Let's see what it looks like. I think everybody knows what we're going to get here. We're going to see a bill of material generated with each one of those assemblies represented with its sub-level parts. I'm going to give the screen moment to update on the webinar. Okay. Here we go. Here's those ball bearings, and here's those bearing retainers, and all those other things that are showing up in this this large bearing. All right, so that's nice. I don't have that. Doesn't meet my needs as far as getting down to purchasing. So what do I do? Yeah. Okay, so I'm going to return back to my CAD system. I'm going to use some SolidWorks features here, but again, this is going to be very similar to other CAD systems. And I'm going to look at this bearing, and I'm going to say, okay, let's see if we can configure this bearing to behave more like, while it's an assembly, I want it to behave more like a part, a purchased assembly. Let's go ahead and open that. In SolidWorks, the setting is set underneath the configurations. Go ahead and set the properties. I'm going to set the properties to this to hide that particular bearing. That means I am in this bearing now. That says to my CAD system that any place this bearing is used, in this assembly or anywhere else, any place this bearing is used, show all the parts inside of my CAD system for engineering purposes, but only show the top level, the bearing assembly as a single line item in my BOMs. Let's set that to hide. Let's go ahead and save these changes back. Okay. Let's update our bill of material. Remembering what it looked like a moment ago with all the subparts in there. Okay. So OpenBOM brings up, I've updated my bill of material from CAD, and OpenBOM renders the new bill of material. Here's our line item 3, and we see now that I don't have any sublevels shown for that. Still identified as an assembly. I still have my same part number. But now as I work my way down through order BOMs and creating purchase orders and things, this is going to show up as a single line item with quantity 1 in my case. Also, any other bills of material that are in use in my company where I'm using this bearing larger 2 will also behave the same way. So what I'm saying is for that particular item, it's a purchased assembly and the subcomponents will not show in the bill of material. Okay, so that's helpful. I do want to I want to demonstrate one other method within SolidWorks that you might find interesting, and we'll make a little bit of a distinction behind it. So here I've set this. I've told my CAD system that this particular bearing always behaves in a certain way. There is another setting that some CAD systems have that do affect this behavior, and there's a nuance to it, but I'd like to kind of take you through it. We're going to look at this disk stack assembly, and I'm going to say, I'm going to edit the properties of its instance. And I'm going to say, look, in this instance, I'm going to use the word envelope. Again, this is a SolidWorks word. It might be different in other CAD systems. Creo, PTC also uses this word envelope. I'm going to say, in this particular instance, and this is more of our second use case. I've already made the first 10 of these my case here, these disc assemblies, and I made those in-house, and I'm going to say, hey, you know what I do? I'm going to send this, I'm going to start buying these from a supplier. In this particular assembly, I'm going to say, put an envelope around that, update my bill of material. And we'll say, okay, so now only in this particular top level assembly, this disc stack is now behaving the same way as the larger bearing, but there's a difference here. In the case of the larger bearing, I've told the bearing, hey, look, wherever you're used in any assembly, you come in as a single line item, you're a purchased assembly. What I've said to this disc stack assembly is only in this bill of material are you a purchased assembly. If that was used in other bills of material, it may still be available as with sublevels. So those are some nuances. I would invite you maybe to look at some of our videos for some additional information on that. So these are the two use cases that I really wanted to address, and that come from CAD. We kind of drive this behavior down through our CAD system. So again, this is based on the item. This behavior we did up here with the envelope is instance based. So, okay. Going to start taking some questions here in just a second. So if you have some questions, please enter them in the webinar panel. Return to the presentation, and we'll wrap this up. Here's some closing thoughts and references on this topic. As I said, this is the 16th in a series of webinars. If you haven't been paying attention or following along, there's a number, if you're just starting to look at these, go back and look at webinars numbers 2, 13, and 14, Essentials to an Effective BOM. I think they lay the groundwork for some of the work that we're doing here. And maybe we'll kind of take you to the next level. We have a video online on purchased assemblies. You can go ahead and take a look at that. These two items here, adding property for BOM structure, these are primarily have to do with the managing purchased assemblies in the non-CAD environment. I'm going to deal with both of these line items in the next webinar on this topic. But what these are saying is, hey, in your bill of material, add a property called source and set it to either build or buy, and then you can sort of affect that behavior that we were just doing through our CAD system. You can get that behavior in your bill of materials if you're not using CAD. Follow along. We have we blog weekly or more on these topics. There's a nice 5 steps to a good BOM management article here that I do like. Maybe you might want to take a look at that. And then finally, there's a link to the webinar playlist down there if you want to get started on that. So with that, I'd like to wrap this up. I'd like to take a few questions if there are any. I see one coming in. Okay. One moment. Okay, let's see. The difference between envelope and configure and hide. I think we discussed that a little bit in the webinar. You can just think about envelope as on a subassembly affecting that particular instance of the subassembly, and the configuration hide show setting is more globally for wherever that part is consumed. If you're using SolidWorks, I kind of went through some of the settings. If you're using Autodesk or some of the other tools, it would be slightly different. And we may have videos on those, and we can certainly answer detailed questions on that at support@openbom.com. Okay. The next one, can I keep my assembly as an assembly and then share it with my subcontractor. Of course, absolutely, of course you can. And let's take a look at what that, I want to watch the time here. Let's take a look at what that, how that works quickly. You know, down here, for example, is a bearing that I still have set as an assembly. Here he is. And I'm just going to open the composed of for that particular bearing. I'm using an OpenBOM feature here to just take me to that subassembly. And now once I'm in that subassembly, I can use OpenBOM share command to simply share this with a particular vendor. So we use a very cloud-based, very familiar to cloud-based users, how we share that out. There's some controls that you have with that. So yes, you could leave your assembly in your upper level and just share it out, and share but only that subassembly with your subcontractor. For example, in the case of the sheet metal. So, okay. Okay, well, I'd like to thank everyone for attending today. Again, we do these every Wednesday. Please watch our blog for updates on the next one, and we would always, of course, we always appreciate hearing from you on this or anything else at support@openbom.com. So have a great day.